Good morning, class. Welcome to the angle pairs and identifying angle pairs lecture. This is the fifth section in the book, and at this point you're probably getting pretty used to these type of videos. Hopefully you've been reading these quotes and getting something from them. Remember, they don't have to be written down in your notes. They're just something to encourage you through the day. The first thing we need to discuss, the first angle pairs, is what we call complementary and supplementary angles. Please note, complementary is spelled differently than giving a complement. Complement in everyday language would have an I right here instead of an E. So this is strictly a math term, complementary angles. It is not giving somebody a compliment. Supplementary, these are, again, just a math term. Alright, so complementary angles are just two angles that add up, that their measures add up to 90 degrees. And supplementary angles are two angles that their measures add up to 180 degrees. So complementary angles, whether they are adjacent, like for instance this angle right here and this angle right here, those two are adjacent angles, and when I add 30 plus 60, that is 90 degrees. These two angles are complementary adjacent angles. The only reason I added the word adjacent is because they're actually right next to each other. This one down here, the 60 degree one, and this 30 degree one right here, they are also complementary. 30 plus 60 is 90. However, they are non-adjacent. They're not next to each other. Remember, for two angles to be adjacent, they have to share a common side. These two do not share a common side. While yes, if I squeeze them together, they would be right next to each other and they would be adjacent. However, they are separate. There's a space between them. They don't have the same side for one of their sides. Therefore, non-adjacent. Over here, this is 150 and 30. If I add 150 plus 30, I get 180 degrees. These two angles are supplementary. 150 plus 30 is 180. Please note, this is also called adjacent supplementary angles. They're next to each other and they share this ray right here, this side. These two down here are non-adjacent supplementary angles. So if you look at this divider here, it divides on the right side the supplementary pairs, and over here the complementary pairs. The top pair being adjacent for both sides, and the bottom pair being non-adjacent for both sides. Another thing to note, all complementary and supplementary angles are pairs. This is a section called angle pairs. I will never say three angles add up to 90 is called complementary angles, because that's three angles. Okay, we can't do three. It's just pairs that we call complementary and supplementary. The first example that you will see is identify and name the supplementary angles, the complementary angles, and the adjacent angles. Now each of these have a measure right here, 68 degrees, 112 degrees, and 22 degrees. Let's start with the easiest part up here, adjacent angles. Those are going to be angles that are touching or have the same side. I look here, this ray BD right here is the only ray that is part of two angles. So this is the only spot where I could have adjacent angles. Angle ABD and angle DBC are adjacent angles. No, there aren't any other complementary angles. I've written them up on the board behind me, but I'll zoom in at the very end with those answers. The next thing, let's just focus on the word complementary angles. Two angles that when I add them together, they add up to 90. So when I look at this 22 plus 112, that's not going to work. That's going to be 134. If I look at 22 and 68, well, 22 plus 68 does happen to be 90. So at this point, angle ABD and angle EFG are both complementary. Please note that this one over here you could just call angle F because it's clear, but this one you would have to call angle ABD or angle DBA. So those two are complementary. The only other case that could be complementary, let's try 68 plus 112. When I add those two together, I'm going to get 180 degrees. So angle F and angle DBC is not complementary, but they do happen to be supplementary. And there we go. Those are all the answers to this problem, written as such. Remember, you could flip the order of any angle around. So for instance, at the top left one up here, you could have angle DBA. For example 2 and example 3, it says given that angle 1 and angle 2 are complements, and measure of angle 1 is 78 degrees, find the measure of angle 2. That is enough information to do this problem. Similarly, if I would look at example 3, I note that it's saying angle 3 and angle 4 are supplements, and the measure of angle 4 is 112 degrees. These two problems are very similar. When I see in example 2, given that angle 1 and angle 2 are complements, right away I know something I can write. I know with just that first phrase, I can write that measure of angle 1 plus measure of angle 2 is 90 degrees. And then I read the rest, and the measure of angle 1 is 78 degrees. Find the measure of angle 2. So I'm going to put in 78 degrees for measure of angle 1, and I'm just going to copy down the rest. At this point, it's just solve for measure of angle 2, so subtract 78 degrees from both sides, and I get my answer to be 12 degrees. Similarly, for example 3, when I see that it says given that angle 3 and angle 4 are supplements, and the measure of angle 4 is 112 degrees, when I hear angle 3 and angle 4 are supplements, I right away can write down this. If they are supplements, that means they add together to be 180 degrees. Just like before, when it was complements, the two angles added together to be 90. At this point, I now plug in that 112 degrees for measure of angle 4, and I solve for measure of angle 3. In this case, it's just subtracting 112 from both sides, and I get that 68 degrees. Alright, and at this point, I've done example 2 and example 3, and then they ask me this question: which angles given above are adjacent? It's a trick question. We don't know any of the angles above that were necessarily adjacent. We just knew that they were complementary and supplementary. It does not say anything about whether they share the same ray, share the same side, nothing. So therefore, my answer would be not enough information. Alright, the next thing we need to talk about is a linear pair. It's just a fancy way to name adjacent supplementary angles. The official definition is two adjacent angles with their non-common sides forming an opposite ray. Remember from before that opposite rays are rays that point in the exact opposite direction and start at the same endpoint. It's basically a fancy way to say two rays that form a line. However, the rays have to start at the same endpoint. That's why they went a little bit more specific. The other pair that we need to talk about is called vertical angles. These two angles are angles that have their sides forming two pairs of opposite rays. So in this example, this red angle over here, angle 2, and this blue angle, angle 1, these two would be opposite of each other, you could think of, in both the terms that this side and this side form an opposite ray, and this side and this side form an opposite ray. Angle 1 and angle 2 are what we call vertical angles. Note, there would be another pair of vertical angles here. This top angle and this bottom angle would also form a pair of vertical angles. Something to note, any pair of vertical angles will always be the same size. So if you see a pair of vertical angles, you right away can say, oh, angle 1 and angle 2 have the same measure. So if you know measure of angle 1 is 45 degrees, measure of angle 2 has to be 45 degrees. With linear pair and vertical angles, the most that you'll generally be doing is saying that vertical angles are the same and getting the same angle measure. And with the linear pair, you'll be adding up the two angles to equal 180, just like we did for supplementary angles. However, we do need to be able to identify them. So at some point, you're going to be asked an example like this. Identify all vertical angles and linear pairs. Let's start with vertical angles just because that was the first one. So what I'm looking to do is look for angles that have the same size and they look like they form two sets of opposite rays. So if I look at this ray right here for angle 1, this opposite ray is this one right here between angle 3 and angle 4. If I go back to angle 1, this is its other side. Angle 4's other side right here happens to be the opposite ray for angle 1 both ways. So angle 1 and angle 4 are opposite rays. If I would then try and do this top and bottom one here, if I look here, angle 5, this is its ray or one of its sides. So its opposite ray would be right here off of 3 and 4. The other side of 5 is right here. Its opposite ray is between angle 1 and angle 2. Note, for this opposite ray, it has angle 3, angle 4. This opposite ray, it has angle 1, angle 2. There is no distinct angle here that is a vertical angle of angle 5. The combination of 2 and 3 would be a vertical angle, but we don't have a name for it. So in this case, the only vertical angles I can list is going to be angle 1 and angle 4. The next one, linear pairs. Remember, this is going to be adjacent supplementary angles, or two angles that form whose non-common sides form opposite rays. So anytime I see just a straight line, this is where a linear pair could happen. So if I just start right here, this here is going to be a line. It's not labeled, so I can't call it anything fancy. So this line right here is what I'm interested in. Two angles that form this line could be angle 1 and angle 5. When I combine those two angles, their non-common sides form a straight line. So angle 1 and angle 5 are what we call a linear pair. Similarly, with angle 5 and angle 4, this is a line that's the non-common sides, opposite rays also, of two adjacent angles. So angle 4, angle 5 is a pair, and angle 1 and angle 5 is a pair. If I would then look at the other case, the top part here, I note that angle 2, angle 3, and angle 4 all combine to make the straight line. However, remember, it's called a linear pair, seeing that there is no two distinct angles. Even though I could make this combination an angle 4 or this combination an angle 1 to be 180 degrees or a straight line, it's not going to work because it's not a pair. For this problem, those are the answers, and those are the ones that we got and discussed about. The last example that we're going to look over today is two angles form a linear pair, and one angle is 3 times the measure of the other angle. What are the measures of the angle? At this point, it's just a word problem. We're going to need some visual help. We are going to draw a picture that will aid us in this problem. I see the word linear pair. Two angles form a linear pair. I'm going to draw a linear pair. This is the linear pair that I chose to draw. Now let's fill in the other information. And one angle is 3 times the measure of the other angle. So one of these angles, I don't know what it is. And I know that the other one's going to be 3 times that measure that I don't know. One angle that is larger is going to be the one that's 3 times the other. So let's make x, or the unknown one, be the small one. And the 3 times x is going to be the large one. This is one of the angles I don't know. And this angle will be guaranteed to be 3 times that angle. And now, I want to know those measures of those two angles. I remember that this is a linear pair, which means those two have to add together to be 180 degrees. At this point, I would write this, because it's true, remembering to include all my degree signs at the appropriate location. At this point, we can ignore the unit, seeing they all have the same unit. Simplify the left side. Solve for x by dividing both sides by 4. That's x. But I was asked, what are the measures of the two angles? The answer will be 45 degrees, and the other one is going to be 3 times 45, or 135. Box up those answers, and I am good. At this point, you should be able to identify both what complementary and supplementary angles are and solve a few problems dealing with them. You should be able to identify to me what exactly a linear pair is and why it's different than a supplementary angle. And you should also be able to look at a diagram, and be able to tell me exactly what angles are vertical angles. Remember, all these 4 are only pairs. If you ever tell me that a linear pair is 3 angles, it's wrong. And you should be able to use any of these to solve a problem in any given situation. Till next time.